Hello and welcome back to our Python programming course. So far we have learned almost everything about tuples. We have learned how to create them, we have learned indexing, slicing, membership operators, tuple methods, and even how to combine and repeat tuples. Now let's learn one of the most interesting features of tuples, packing and unpacking. Now don't worry about the names. They sound difficult, but once you understand the concept, you'll realize it's actually very simple. So let's begin with tuple packing. Now imagine your clothes into a suitcase before going on a trip. Instead of carrying every shirt, every pair of jeans, and every t shirt separately, you put everything into one suitcase. In programming, tuple packing works in a very similar way. Now, instead of keeping multiple values separate, Python packs them together into a simple tuple. Let's understand that small thing using a simple example. So let's create the file python lecture10.py. Now if I write student is equals to Rahul, then 20, then computer science. Now we have already written this code before. But here's something interesting. Python allows us to create exactly the same tuple without writing parentheses. Let's run this first by printing student. Now we'll see the output. So the output is the tuple we stored in that variable. Now let's remove the parenthesis from here and let's run the output then. So we get the same output. We didn't use parentheses anywhere. Even then Python created a tuple. Why? Because Python automatically packs multiple comma separated values in a tuple. This process is called tuple packing. So whenever Python collects multiple values together into one tuple, we say those values are packed. Now let me ask you a question. Which of these two methods is correct? So first time I am giving parenthesis. This is method 1, and now if I write student is equals to Rahul, comma 20, comma computer science. The answer is both are correct. Most programming prefers the first method because it is easier to read. However, you will often see the second method in professional Python code, so it's important to recognize it. Now, let's move to the opposite process. If packing means collecting values together, what do you think unpacking means? Exactly. It means taking those values back out of the tuple and storing them in separate variables. Now let's understand this with an example. So let's delete this. Now instead of accessing each value using indexes like print student 0 and then print student 1 and similarly print student 2. This is the normal way of accessing each and every element from the tuple, but Python gives us a much cleaner approach. Now if I write like this, name, comma, age, comma, course is equals to student. And then if I write print name, okay, so before this part, let's run this first. So if I get the output as Rahul, then 20, then computer science. Now what if instead of this I write this, then print age, then print student. Now let's run this and we'll see if we get the same output. Instead of student, if I print course over here. So now let's see if we get the same output. So yes, we get the same output. Let's understand exactly what happened. Python looked at the tuple. The first value Rahul was assigned to the variable name. Then the second one was assigned to the value age, and the third one was assigned to the value course. This process is called tuple unpacking. Notice how clean the code looks. Instead of writing three indexing statements, we extracted all the values in a single line. This is one of the reasons unpacking is widely used in Python. Now let's intentionally make a mistake. Type the following code with me. So instead of course, if I write name comma age is equals to student. Now before running the program, think about what might happen. The tuple contains three values, but we have created only two variables. Can Python fit three values in two variables? Let's run the code and then we'll understand this. So we get an error. Python immediately gave an error. The reason is simple. The number of variables on the left side must match the number of variables in the tuple. If there are three variables, you need three variables. Similarly, if there are four variables, you need if there are four values, you need four variables. Now let's correct the program again. So name comma age comma course. Now everything works perfectly. This is an important rule that beginners should always remember. The number of variables must match the number of elements being unpacked. Now let's look at one practical application. Suppose a function returns multiple values. You don't need to study functions right now. Just imagine that some code returns a student's name and marks. Now, instead of storing everything in one variable and accessing indexes later, you can unpack the values directly into meaningful variable names. So, this makes your programs much easier to read and understand. And that's one of the biggest advantage of tuple unpacking. Now, we have learned packing and unpacking. We have covered almost all the important concepts related to tuples. Let's understand this topic with a small practice activity. Topic with some practical examples. So let's finish our tuple topic with some practical examples. Now at this point you know what a tuple is, how it differs from a list, how it accesses its elements, how to slice it, how to use membership operators and how to count and find elements, how to combine tuples and how to pack and unpack values. Now the important question is, where would we actually use a tuple in a real Python program? Let's look at a few situations. Suppose we are storing the coordinates of a point on a graph. A point can be represented using two values, the x coordinate and the y coordinate. For example, point 10 is equal comma 20. Now Here 10 represents the x coordinate and 20 represents the y coordinate. These two values belong together. And normally, once we have defined a particular point, we don't want the coordinates to be changed accidentally. That's a good situation for a tuple. We can access the coordinates using print point 0 and then print point 1. So the output should be 10 and 20 as expected, and yes, we get that same output. So we can also unpack them with writing x comma y is equals to point. Now what if instead of point 0 I write x and instead of point 1 I write y? So let's see what actually happens. Now will the output be the same? Let's see. And yes, so this is much easier to read because the variable names themselves tells us the each value themselves tells us what each value represents. Now another common example is storing fixed information such as the dimensions of an image, like resolution is equals to 1920. So resolution is equals to 1920 comma 1080. Now, here the two values represent the width and height. We don't want to randomly change the structure of this information, so a tuple can be appropriate. Another example could be RGB colors. For example, red is equals to 255, 0, 0. Now the tuple represents the RGB values for red. The first value represents a red intensity. The second represents green intensity, and the third represents blue intensity. Now again, these values naturally belong together. Now let's build a small project. Imagine that we want to store some basic information about a student. Now you can write this with me. So create a tuple student storing the name, the age, and the course. So here we have three values. Let's firstly ah. So here we have three values: the student's name, the student's age, and the student's course. Now let's unpack the tuple using name, comma, age, comma, course is equals to student. Now we have three separate variables for each and every values. Now let's display them in a readable format using print name comma name and then print age comma age and then lastly print course comma course. So let's see what we get the output as. So yes, we get name Sam, age 20, course CSC. Notice how clean this program is. We used one tuple to store complete student record and then unpacked it into meaningful variables. Now let's try to modify the student's age. So if I write student, so if I write student 1 is equals to 21. What do you think? Will the second element will be changed from 20 to 21? No. Python will produce an error, that is type error, because the tuple is immutable as we have discussed it earlier. Now, if the student's age actually needs to be changed, then perhaps a tuple isn't the right data structure for that particular situation. This brings us back to the most important question: when would we use a list and when would we use a tuple? Let's make the distinction. Let's make the distinction very simple. If you have a collection of data that is expected to exchange, a list is usually appropriate. For example, a shopping list, a list of students attending a class, a list of products in a cart. These things can change frequently. But if you have a collection of related values that should remain fixed, a tuple can be a better choice. For example, you are going to save coordinates, RGB values, dimensions, fixed, fixed configuration information. So don't think of tuples as simply lists that can be changed. Think of them as a way of representing a group of values that should remain together and unchanged. Now, let's test what you have learned. So pause the video and try these questions yourself. So the first one says that create a tuple containing your name, age, favorite sport, and then print the tuple. And using the same tuple, print only your age using indexing. Now print the last element. Now pause the video and try these questions yourself. So the first one goes like create a tuple containing a name, age and favorite sport and then print the logic. The second one is use the same tuple, print only your age using indexing, and then print the last element using negative indexing. Now create this topic. So numbers is equals to 10, 20, 30. So numbers is equals to 10, 20, 30. So let's unpack it into three variables called a, b, c is equals to number. Now then we'll be printing these three values. So print a, then we'll print b, and then we'll print c. Now create a tuple containing repeated values. For example, numbers is equals to 10, 20, 10, 30 and 10. Use count to find how many times 10 appears. So you can take a few minutes and try solving this yourself. Don't immediately look for the solution. The goal isn't just to understand the code when someone else is writing it. The goal is to become comfortable writing it yourself. Now let's quickly summarize everything we have learned about tuples. So a tuple is an ordered collection of elements. We normally create it using parentheses. For example, data is equals to 10, 20, 30. Now tuples support indexing, they support negative indexing, they support slicing. They support membership operators such as in and not in. They have two important methods. The first one is count and the second one is index. So we can combine tuples using plus, we can repeat tuples using asterisk, and we can pack them into a tuple. And we can unpack tuple values into separate variables. So most importantly, tuples are immutable. That means their existing elements cannot be modified after the tuple is created. Before moving to the next topic, I want you to complete these problems. So the first one goes like is create a tuple containing five numbers. So we'll be writing a program that is create a tuple containing five numbers, the first element, the last element, the first three elements, the last two elements. Now create a tuple containing the names of five students and ask the user for a name and check whether a name exists in the tuple using. Now the second last one is create a tuple containing repeated numbers and use count to find how many times a particular number occurs. And the last one is create a tuple containing three values, age, course. Unpack the tuple into three variables and display the information. Now, homework 5. Create two tuples containing different sets of different. Create two tuples containing different sets of numbers. Combine them into one tuple using the operator and then print the final tuple. Now that completes our introduction to tuples. We started with a single question. If list can store multiple values, why do we need tuples? And now I guess we have the answers. So let's be careful when the collection needs to change. Tuples are useful when the collection should remain fixed. In the next part of this lecture, we are going to learn about another completely different collection called a set. And sets solve a problem that neither lists nor tuples solve particularly well. Now, how do we store a collection where duplicate values are not allowed? Now, let's move on to our next Python collection, that is sets. So, before we learn the syntax, I want to start with a problem. Imagine you are conducting a survey in your college. Now, you ask students which programming language they know. Then you collect the responses and store them in a list. So let's write it as languages is equals to. So we are first of all storing it in a list. So Python, Java, then again Python, then C++, then Java. And then if I write Python again, so suppose you collect the responses and store them in a list. So let's say the responses are stored in a list like languages is equals to Python, then Java, and then again Python, C++, and then again Java, and lastly Python. So yes, we have got our list and let's print it first. So print languages. Now let's see the output. So let's see the output. So as expected, Python appears 3 times, Java appears twice. But suppose the question we are trying to answer is not how many students are selected each language. Instead, the question is which different programming languages are present in the survey. In that situation, we don't really care about the repeated values. We only want Python, Java, and C++. This is exactly the kind of problem that sets are designed to solve. Now, a set is a collection of unique elements. In other words, a set does not allow duplicate values. So let's see this Python. So let's see this in Python. I'll be creating a set using curly braces. So languages is equals to curly braces, and then we'll be writing Python, Java, then again Python, then again C++, then Java, and then again Python. Now let's try to print languages. And when we run this code, we'll get something similar to this: Python, Java, C++, or Java, C++, Python. The exact order may be different, and this is something very important about sets. Unlike lists and tuples, sets are unordered collection. So don't expect the elements to remain in the same order in which you entered them. So if I try this again, we are getting the different order. If we had started from Python, then Java, and then C++, but we are getting something different. We are getting Java, Python, and C++. Now, the most important property here is that duplicate values are automatically removed. We entered Python 3 times, 1, 2, and 3. But when we see the output, the Python is only present once. Now Java was twice in the set, but it only prints once. Now C++ was once, so it gets printed once. So we can remember the basic idea like this. List allows duplicate and maintains order. Tuple allows duplicates and maintains order but cannot be modified. But set does not allow duplicate and does not guarantee order. Now let's compare them visually. Be writing We'll be using numbers and we'll be storing in list first. So 10, comma 20, comma 30, comma 40. Let's write 10, comma 20, comma 10, comma 30. And then tuple is equals to 10, comma 20, comma 10, comma 30. Now if I write set is equals to 10, comma 20, comma 30. Let's see. Now notice that both the lists and tuples keep the duplicate 10, 10. Now the set removes it. You'll be seeing it like if I write 10, comma 20, comma 10, or 30. Now I'll be printing it. So we can see 10, 20, 10, 30, 10, 20, 10, 30, and then again 10, 20, 10, and 30. I'll be printing each and every one. So print list, then we'll print tuple, and then again print set. So we'll compare the by seeing the output. So now if we see the output, that list prints 10, 20, 10, and 30. That is, it allows duplicate values, and same with the tuple. But if you see the set, it only prints 10, 20, and 30. So the set removes the duplicate values. So this is one of the biggest reasons we use sets. Now, now let's create a simple set of numbers. Like, let me remove this first, and then if I write 10, comma 20, comma 30, and then 40. If I write print set, let's see the output. The output is 10, 20, 40, 10, 20, and 30. Then, so, this, so by this we can observe the order in the set is not fixed. So the output will contain those four values. Now let's add duplicate values. So 10, 20, 30, 40, and then again I will give 20. Now let's see the output. So the output is again 40, 10, 20, and 30. Even though we wrote 20 twice, the set contains only 120. This isn't an error. Python simply ignores the duplicates. Let's let's try something else. So if I write 10, 10, again 10, and then 20, again 20, and then 30. Let's see this. So we get 10, 20, and 30. Again, duplicates are automatically removed. So if your main goal is to store unique values, a set is often a much better choice than a list. Now, an important difference, order. Now let's compare a list and a set. So let's create a list first. So list is equals to 10 comma, so list is equals to 10 comma 20 comma 30 and then 40. Again in set also we'll be writing same thing. So 10 comma 20 comma 30 and then 40. Now we'll be printing list also. Now at first glance they look almost identical in terms of their values, but their behavior is different. A list is ordered, that means we can rely on the elements having positions. For example, if I write, firstly we'll say the order is same or different. So we can see the order different over here. The list is 40, 10, 20, and 30, but while the list is the set is 40, 10, 20, and 30, while the list is 10, 20, and 30, and 40. So the list follows its order, but the set isn't following its order. Now we'll again try to understand this with a simple example, that is list 0. If I write list 0, 10 should get printed, and yes, output is 10 because 10 is at index 0. But what if we write print set 0? Should we get 10 only? Let's see. Python gives a type error. Why? Because sets do not support indexing. There is no guaranteed first element, second element, or third element in a set in the way there is a list or tuple. But this is extremely important. So don't treat a set like a list. If you need positions and order, use a list or tuple. If you mainly need unique values, a set may be the better choice. Now, here is a small Python trick that beginners often get wrong. Suppose I want to create an empty set. So a beginner will write empty is equals to dictionary, or empty is equals to curly braces. At first glance this looks like an empty set, but it isn't. In Python, this empty curly braces represents dictionary, not an empty set. We'll learn dictionary later. So, if you actually want an empty set, you need to use set parenthesis. Now let's check it by writing print empty. The output would be set. So yes. So remember this carefully, that if you write this instead of set parenthesis, this won't create an empty set. This is one of those Python details that can cause confusion later, so it's worth remembering now. Now, what can a set contain? Just like lists and tuples, sets can contain different types of values. For example, if I write data is equals to Sam, then the age, and then a floating point number, let's 85.5. So Sam is a string, 20 is an integer, and then 85.5 is a floating point number. Now Python allows this. However, there is an important rule that we will discuss in more detail later. But every Python object can be placed inside a set. For now, focus on the main idea. A set is designed primarily for storing unique values. Let's imagine you are organizing a college event. Students register using their college ID. Some students accidentally register more than once. Suppose the registrations ID are 101, 102, 103. And again, someone registers with 101 and then 104, 102, and 105. So we'll see it by writing the registrations is equals to set. So 101, we're storing it in list first. So 101 comma 102 comma 103, and then again 101, then 104, then 102, and if I again write 105. Now if we print the list, we can now if we print the list, we can see the duplicate registrations. So let's see. So print registrations, and yes, we can see 101 twice, 102 twice. But what if we want only the unique registration IDs? We can convert the list into a set. Now how we'll do that? So we'll write unique or a new variable name like unique registrations is equals to set registrations. Now if I try to print unique registrations, let's see the output. So the result, so the so the result should contain each ID only once. And yes, 101, 102, 103, 104, and 105. So there 101 and 102 are not repeating like the list. Maybe the exact order may vary because sets are unordered, but they don't store duplicate values. This is a very practical use of sets. Now, whenever you have a collection of data and need to eliminate duplicates, converting it into a set can be extremely useful. Now, let's test your understanding. What would you use if you needed a shopping list where the order matters and duplicate items are allowed? Your answer should be a list. And what would you use if you had fixed coordinates such as 10, 20? A tuple. And what would you use if you wanted to store unique student registration IDs? Your answer should be a set. And that's the basic mental model I want you to develop. Don't choose a data structure just because you have memorized its syntax. Choose it based on the problem you are trying to solve. Now, in the next section, we'll learn how to modify sets, and then we'll see how to add elements and multiple elements, remove elements, and understand the difference between methods such as remove and discard. Now, we have already learned how to create sets, why sets don't allow duplicate values, and how to add and remove elements. Now, let's learn the feature that makes set especially useful: set operations. So set operations allows us to compare two groups of data. Now we'll learn four main operations. So the first one is union. So we'll be writing over here, so union, and then intersection, then comes difference, and lastly it's symmetric difference. So let's understand them with a simple example. So firstly we'll be commenting out the whole part, and then let's do. So imagine we have two programs of students. So imagine we have two groups of students. Group A contains a student who know Python. So we'll be writing Python students is equals to Rahul. Then Aman. Then we'll be writing Priya, and then Riya. So this is the group A students, and now we'll be writing group B students, that is Java students. So the names goes like Aman, Riya, Karan, and then Neha. Notice that Aman and Riya are present in both the groups. Now let's see what we can learn from this data. So firstly we will be practicing union. So suppose I want to find all students who know either Python or Java. I don't care whether they know one language or both. I simply want everyone from both groups. This is called the union. So we can perform it using the union function method. So all students is equals to Python students dot union, and then within the parentheses we'll be writing the different group, that is Java students. Now that's it. You have already stored the union of Python students and Java students in all the students. I'll be printing the variable print all students. Now before actually seeing the output, can you guess the output? And yes, you're right. So we'll be creating all the students. So Rahul, Priya, Aman, Karan, Riya, and Neha. The exact order may vary because we are working with sets. Now notice that Aman and Riya appear only once. Aman from here and Riya. Now this were the two names that were present in both the groups, but when we printed the all student variable we got it only once. This is where sets come in use. We already have studied that sets only shows unique data. It won't duplicate the values inside the set. So the operator can be useful only once you are comfortable with sets. So let's move to the second operation, that is intersection. So now let's ask a different question. Which students know both Python and Java? Look at our two sets. Aman is present in both, and then Riya is also present in both. So these are the students common to both groups. This is called the intersection. We can use the intersection method similar in a similar way. Instead of writing union, we'll be writing intersection. and all students should be common students because we need the literal meaning of variables. So here we go. Now again the order may vary, so we'll be seeing, and yes, we get Aman and Riya. So remember, union everything from both sets. Intersection only the common elements. A simple way to remember this: union means combine and intersection means common. Now the second last is difference. Now let's ask another question. Which students know Python but do not know Java? Look at group A. Rahul is only in Python. Aman is in both. Priya is only in Python. And then Riya is in both. So the answer should be Rahul and Priya. This is called the difference. Now we can write like this. So instead of intersection, we'll be writing difference over here. So difference, and then instead of common, we'll be writing Python only students. So Python only. Now the output should be Rahul and Priya. So we get Rahul and Priya. Now this is the exact output we wanted. Now we can see this statement, that is Python underscore students to difference. Now Java students inside the parenthesis. This means elements in Python students that are not in Java students. But if we reverse it, instead of writing Python students, we will be writing Java students. And then instead of Java students, we'll be writing Python students. Now we get students who know Java but not Python. Now we get students who know Java but not Python. That would give us Karan and Neha. So unlike union and intersection, difference is directional. Now there's one more useful operation, that is symmetric difference. Now suppose I want students who know only one of the two languages. I don't want students who know both. So Rahul qualifies, Priya qualifies, Karan qualifies, and then Neha qualifies. But Aman and Riya don't qualify because they know both. This operation is called symmetric difference. Now instead of difference, we'll be writing symmetric difference over here. So symmetric, then underscore. So let's see the result. So the output is Neha, Karan, Rahul and Priya. The result contains the students who belong to exactly one of the sets. This is useful when comparing two groups and you want to find the values that are unique to each group. Now there are two more concepts worth knowing. So the first one is subset and the second is superset. Suppose, let's clear it out first. Now if I have A, and then we'll be storing 1, 2, 3, 4, 5, and then in different set we have 2, 3. Now look carefully, every element in B is also present in A. So we can say that P is a subset of A. We have already learned this in maths. So Python allows us to check this using is subset. So if I write print P dot is subset is subset A. Now let's see the output. The output should be true, and yes, we get true. Now we can ask the opposite question. Is A a superset of B? Since A contains every element of B, the answer is again true. So instead of B over here, we'll be writing A, and instead of is subset, we'll be writing is superset, and then instead of A, we'll be writing B. So this statement means that A is superset of B or not, and this print will actually print the output of this. So let's see. So the output is true. Now you don't need to remember this concept deeply right now. So just remember subset. Every element of the smaller set exists in the larger set, and superset is the larger set contains all elements of the small set. Now we will be writing it as our short note. So subset is equals to every element of the smaller set exists in the larger set, and then superset is the larger set contains all elements of the smaller set. So that's it about superset and subset. Now let's finish our set topic with a practical example. Now imagine you are organizing a college event. Students register using their student IDs. Some students accidentally register multiple times. So we receive a data as registrations 101, 102, then 103, and again 101, 104, 102, 105, and 103. We have seen this similar set previously also, but because instead of set we'll be storing it in a list first, so let's store it in a list. So that's it. Now because this is a list, duplicates are present. Now if we want only unique registrations, we can convert the list into a set. So how we will do that? We have already seen this. So unique registrations is equals to set registrations. Then if I try to print unique registrations, what is the output we would be getting? Every registration ID appears only once. We can even compare today's registration with yesterday's. So let's see the output over here. And the output is 101, 102, 103, 104 and 105. So there are no duplicate values. Now suppose instead of this we get something as, let's write yesterday is equals to 101, 102, 103, 104. This is the yesterday, and now today is equals to 103, 104, 105 and then 106. Now which students registered on both the days? We'll be seeing it using intersection. So print yesterday dot intersection, then inside parenthesis we'll be writing today. So by seeing the both sets, you can assume the output as 103 because it's present in both the sets, and 104. So let's see. So yes, the output is 104 and 103. Again, the order is not a topic to be talked about here. So which students registered today but not yesterday? Let's see that first. So we'll be writing difference over here. So difference. Instead of yesterday, we'll be writing today. Instead of today, we'll be writing yesterday. Why? Because we want students who have registered today but not yesterday. So let's see the output. The output is 105 and 106. And then which students appeared in either days? That should be union, because we want students who have registered in either day. Maybe it will be yesterday or maybe today. So let's see union. The output is 101, 102, 103, 4, 5 and 6. Now you can see why set operations are useful. We are not just manipulating random numbers, instead we are comparing real groups of information. Now let's quickly summarize the important things we have learned about sets. So a set stores unique values, does not guarantee order, does not support indexing, can be modified, and automatically removes duplicates. Now what were the important methods that we included? It included add, update, then remove, then discard, then pop, and then clear. These are the syntax of all these methods are similar as used in lists and tuples, so you can do it in your own. And now, important set operations include union, intersection, difference, symmetric difference, is subset, and is superset. The four operations I especially want you to remember are union, everything from both sets, intersection, common elements, difference, element present in one set but not in the other. Now, symmetric difference, elements present in only one set, only one of the sets. Now that's enough for you to start using sets confidently. You don't need to spend another long section on sets because the core concept is actually quite compact. Now we are ready for the final and most feature-rich collection of this lecture, that is dictionaries. And dictionaries are fundamentally different from everything we have learned so far. With lists and tuples, we access data using positions. With sets, we mainly care about unique values. But with dictionaries, we all associate one piece of information from another using key value pairs. For example, instead of remembering that index 0 contains a student's name and index 1 contains their age, we can directly write student is equals to name, then we'll be storing the name of the student, so Rahul, comma, and then again we'll be storing age, so the age is 20, and then course. That is CSC. Now we can ask Python for the student's name instead of remembering its position. That's what makes difference. That what that's what makes dictionaries so